Hi guys, so this video serves as a complement of the class demo from last week. So in this video I will briefly talk about the whole structures of the systems that you guys will use in your PS3-3 assignment. Hopefully after you guys finish this video, you guys will feel more confident in finishing the PS3-3 assignment. So let's begin. So first, let me briefly talk about the broad picture of the systems that you guys will be working with. So this IoT system has 5 clients. As you guys can see, here is the camera capturing client, the image processing client, the motion planner client, RoboArm clients, and turntable clients. All these clients communicate with the server. They upload and download data from the server. So basically, these 5 clients communicate with each other through the server. However, although there are 5 clients, there are only 3 groups. So what I mean by 3 groups? So there's the camera group, the ARM group, and turntable group. So these groups are categorized by its function. So this camera capturing and image processing clients, they are only dealing with the camera thing, and this motion planner and the RoboArm clients, these 2 clients, only deal with the dense RoboArm, and the turntable deals with the turntable. So that's why we separate the 5 clients into 3 groups. So let me talk about each of the clients. So the camera capturing client, so basically it captures images and then it sends images to the server, and then the image processing clients download the image from the server, and then it starts to process the image. And after the image is processed, it sends the information to the server, and the motion planner downloads the information, and then it starts to do its motion planning job. And after the motion planning is done, it sends the optimal path to the server, and RoboArm downloads that optimal path, and then the RoboArm executes. This RoboArm client executes the dense RoboArm command, and the dense RoboArm will move accordingly. And also here are the turntable clients. So basically what the turntable clients does is that it will, when the human imagine that there's a worker that stands by the turntable, it will press the button and the turntable will turn, and then all the other clients will automatically do their jobs. So the turntable will actually be running in the middle of some of these clients. I will talk about this in detail in the rest of the video, so you guys don't need to worry about this right now. So as for right now, you guys only need to know that all these 5 servers send data and download data from this server, and then they start to do their own job accordingly. So here are the 2 notes I need you guys to know. So first, although there are 5 clients, we only have 3 status to set. I've already talked about that. So basically, this camera capturing and image processing clients, they are within this camera group, and on our server side, both of the 2 clients sets the status of the ARM camera. So basically, when you are working with image processing clients, you only set the status of the ARM camera status. You don't set the status of the ARM status, and you don't set the status of the ARM table status. Same here, when you work on the motion planner, you only set this client status to the ARM status. You don't set this client ARM status to the ARM table status and the ARM camera status. Same here. Although you don't touch this part, but when we write the scripts, the turntable only set its client status to the ARM table status. It doesn't set it to the ARM status and the ARM camera status. So make sure so basically this image processing part and the motion planning part are the only two scripts that you guys will work on in this PS3-3 assignment. This image processing client is called PS3-3 camera client.py, and this motion planner is called the PS3-3 ARM client.py. So these two Python scripts are the only two things you guys need to work on in this PS3-3 assignment. So make sure when you guys are working on these two clients, set its client status to its own group status. Don't touch other groups status when you guys work on the scripts. Okay, that's pretty much about this introduction. So for the rest of the videos, I'm going to talk about pretty much a very similar content to the So for the rest of the video, I'm going to talk about the content that is very similar to the class demo from last week. So if you feel good or you feel confident in finishing this assignment, you don't have to watch the rest of the videos. You can just skip it. Yeah. Okay, let's begin the next part of this video. Hey guys, what's up? So I'm going to talk about your assignment, PS3-3 assignment. So hopefully after I go through this assignment briefly, I will help you guys finish this assignment more easily. So let's begin. So basically this assignment aims to let you guys understand the concept of how the IoT client works. So in your PS3-1 and PS3-2 assignments, you guys have finished the motion planner and OpenCV for the image processing. Now it comes to the PS3-3 part, and we want you guys to integrate all the clients together, let them communicate with each other through the server. So in this tutorial, I will show you guys how the system will look like, the whole system will look like after you guys finish the assignment. So let's begin. So the first thing I want to say is that we have a very detailed README file in this folder. So we send you this README file. It's in this PS3-3. It's in this. No. Yeah, it's in the source file, and you guys can see here is so the source file is what we're gonna send to you, and in this source file you will see this README file here. And you guys need to open it and look at it first. It has a very detailed instructions for you guys to how to run and do your homework. So let's begin. So first thing, when you guys start to do the homework, is to show the robot arm visualization. So that has been done using this ROS launch the Denso robot turntable bring ups. That's what you guys used in your PS2 assignment, and we add the cameras in it. So that's the first thing you need to launch. And of course, before you launch, don't forget to source the ROS environment. So after you launch this, you guys will see arrays and gazebo here, and also the arrays. You guys can see here the camera, and this is the turntable here, and the gazebo gonna synchronize with these arrays. So for this tutorial, I will just focus on that you guys see the arrays, because since the gazebo does nothing different from these arrays. So after you guys launch this visualization, you guys need to launch this Denso interface, Denso robot interface. So this Denso robot interface is used to control this Denso robot arm in this arrays, and make sure you guys launch this Denso robot interface after the gazebo, because if you guys launch this Denso robot interface first, it cannot find the robot arm in the visualization software. So basically it has nothing to control, so it will report errors. So make sure you guys launch it secondly. So now I'm launching it. So after launch it, here's my third command: reset the servers. So this ROS service call calls a table turner, and this table turner is written in this Denso robot interface. We've written that for you. So basically what you guys need to do is just call this table turner and then reset status in the server, and then you guys will reset the status of all the clients on the server side. And make sure you guys can, this command is very long, so basically you guys can just type T and tape complete, and then reset. You type R, type R, and then tape complete, and then tape complete for the argument, and then success. So basically here you guys can see nothing, but here change something, something changed, and actually on our server side all the status of the clients have been reset. So third thing here is you guys can see, so basically I want you guys to see actually so here is the server, and you can see here I just set complete, and you can see at the time right now shown, and the ARM status complete, and also table status. It's almost the same time, you can see, and the status shows complete. That's reset. And also think the ARM status here. Yeah. You can see also same ID here, and the status complete almost at the same time. That's basically what I just did. And then you guys should launch this camera client, so that you guys can download the camera and download the images and then process the thing. That's for the sorry, this is the ARM client. You guys can open this as well first as well. Doesn't really matter actually. And this is the camera client. Sorry about that. Flips over here. So it doesn't really matter which one opens first. But just be consistent with the readme. So just do that. So basically, I launched the robot arm command and the robot and the camera the robot arm client and the camera client. What the camera client does is to download image from this arrays, and then do the offensive image processing, which you guys have done in your PS3-2 assignment. And what this robot arm client does is do the motion planning after you guys finish the process your image, and this robot arm client download the points which is sent from this camera client, and then this robot arm client will do the motion planning and then send the order of the points and also the status of the robot arm to the server and command the robot arm to move. So here the last command here is turntable. So you guys can see here the pieces are here and the robot arm is here, and the camera can see nothing actually in this region here. So imagine that there's a person standing here and you want to turn the table and the camera see these pieces, and then the worker turn the table again, the pieces approach this robot arm and robot arm can do the job, and then the worker keeps putting the pieces on the turntable and then turn the robot arm, and then press the button to turn the table, and the table keeps turning, and then the robot arm keeps putting the red piece on this green piece and keeps doing this job. So that's basically how this IoT system looks like, and that is how the workflow of the systems look like. So now I'll turn the table. Make sure you guys see this picture here. So nothing is in these regions right now. So I'll turn the table. After I turn the table, you see some changes here, and also some changes here is success, and you can see so this RVs. So you can see the turbo turn here to here, and some pieces are visible in this region, and also the camera client now have downloaded the image and then do the processing, and then you can see the robot arm, it only process this region, and then the camera only process this region on the turntable and found the position of the piece, and then it will send the positions to the server again, and let the motion planner do the motion planning. And this thing it will be so in order, and this motion planner and the robot arm and the turntable turning actually happens concurrently. So when you turn the table, at the same time the motion planner will begin to plan the path, the more optimal path for the robot arm to move. So when you turn the table again, so we can see where do you want to turn table, because these pieces are still not close to this robot arm. So in order to let this piece be closer to the robot arm, you need to turn table again, and this is also a signal that fires robot arm to fires the motion planner, and also then the robot arm will start to work. Turn the table, and you can see the table turns again, and the motion planner has been done instantly, and then this robot arm begins to work. You guys can see when you guys do the assignment, make sure not only the positions matches, but also this orientation, the robot arm's orientation matches the orientation of these pieces here. And I imagine that the red parts are put on the green part, and these red parts are put on this green part again. Oh, and so here there's a crazy motion due to the move it, our motion planner, and it's actually server library. So this is a bug, so you guys don't need to care about that. So we are still trying to fix that, but probably not in this assignment. And you guys can see the robot arm finishes motion. of the turntable, and now you can see this I'm stuck. So basically, so nothing has happened. So basically, robot arm stops here, and the turntable is not turning, camera is not turning. So in order to trigger next steps, what you need to do is to turn the table again, because actually now you guys can see these things here. So it's another set of pieces. These pieces have been seen by this camera, and the camera sends these pictures to our OpenCV client, and then the OpenCV client, see here, upload 8 objects information. So basically this is OpenCV client. So basically it download the image and then do the image processing again, and then found the positions of all the pieces and also the orientations, and then upload its object information to the client for the motion planner to download and then do the motion planner's work. So here, so basically after this robot arm's done, after this robot arm finishes work, all the things, so the image capturing and the image uploading, downloading, and the processing have been done as well. So we are not wasting any time. So if you turn the table again, see, turn the table again, the robot arm will start to work again, because the motion planner has already done its job, and then the robot arm start to work again. Same thing here, you need to take care of the orientations and the positions of the robot arm and these pieces. So that's a requirement for this assignment. So for this time, the OpenCV pictures that was popped up for the 4 pieces here is not showing up. Usually you don't really show them up. Usually those pictures are not showing up, but for the first round, I just want you guys to visualize like how the image is processed. So that's why I use the cv2.im show to show the images, but usually we don't really show those images. Okay, so the robot arm has done its job. So now the camera doesn't really see anything, and the same logic applies here. So when the robot arm was doing its job, the image has been already captured and upload and then download by the the OpenCV image processing client. Sorry. But here there's a problem. You see, there's no object here, so camera see no object. So when the camera see no object, you need to take care that. So when you turn the table, you guys need to make sure that the robot arm does nothing, since there's no object here. So that's one thing you guys need to figure out in your assignment, how to make sure that the robot arm functions normally when these special cases happen. So you guys can see here, after turntable, the camera still sees nothing in this region, in this comb region. So I expect robot arm not to work after turntable, and still robot arm does not work. See, and also, so I've turned the table I've already turned for over a round actually. So the camera sees these 4 pieces again. So imagine these 4 pieces are new pieces the worker put on, and then the image sees these things, sees these pieces, and then you need to turn the table again for the robot arm to work on these pieces. See, the robot arm starts to work again. So basically, you can see here pretty much complete our systems, because the whole pattern will just keep repeated. And imagine that these parts here are actually not fixed on the table. They're like randomly, like the worker standing here puts all these parts randomly in these partitions. And then when the table is turned, all these pieces will be processed through this IoT system, and then the robot arm, the camera will work together to make this whole system work efficiently by communicating with each other. Okay, so basically that's what we expect you guys to do after you guys finish this assignment. That's the system we expect to see. So this is pretty much about this demo. However, we know that you guys probably gonna have some problems with the assignments. I will go through the assignments really quick and let you guys know what you guys need to work on. Okay. So basically these are the two scripts you guys need to work on. That's it. So we've written a lot of things already. So we've done the ROS part, the ROS part, so you guys don't need to touch that part. So the assignment for this part is just the goal of this assignment is to let you guys understand the concepts of the IORT and let you guys have a brief understanding of how each client communicate with each other. So these two scripts are basically the only two Python scripts are the only two scripts that you guys need to work on, and they are located in this source file. So this source file folder is what we will send to you. And in this source folder, go to the PS3, and you guys will see. Go to the source again, and you guys will see these. There are like 4 Python script here, and you guys only need to work on this PS3-3 ARM client and the PS3-3 camera client.py. And maybe you guys also want to look up this IORT ARM.py, but I will talk about that later. And also make sure when you guys execute these Python scripts, don't use any ROS command, just use Python, then use Python to execute these scripts here. Because these 2 Python scripts are not written in ROS environment. Okay, so let's talk about this assignment here. By the way, let me talk about these things first. Sorry. So everything was going behind the scene, and everything data transfer happens on this server. So you guys can log in. I showed you guys early time, so you guys can check it out if you guys don't remember how to log in. So here you can see this was when the first time when I reset the status, and if I refresh this, and you can see here the time changed. Sorry, here, I think here, yeah, this one. Oh yeah, this one is the one I have shown you guys. So you guys can see this thing, the time changes, and it's showing planning. It's probably because I didn't really close it in a very good way. I just Control C and force them to close. That's a bad habit. You guys don't do that. But when you guys reset the status, all the things will be reset. So the status will be reset to completed. but basically it shows that the time change. So basically everything, every data and every data that you guys have done on the client is sent to the server, and you can see all the data here, the position, the pieces positions, the rotations, and what color of the pieces is. All these things, all these things have been uploaded to server. So if you guys want to check out the data, you guys can log into the server and see how the data is uploaded and whether you guys successfully uploaded the data. And I think here is very easy to understand just by the name, by reading the name of these columns. So I don't expect you guys to have any troubles on reading these things. Okay, let's talk about our assignment here. So first thing I want to talk about is the camera client. So I suggest you guys to work on this script first, because the ARM client depends on the camera client. So if you guys work on the ARM client first, you guys probably don't have a way to verify if your script is written in a correct way or not, because you guys cannot download the data, because the camera client will send the data to the ARM client. So let me start from the main function here. Yeah. So in the main function, we have already gave you guys a sample code. So basically, what we expect you guys to do in these two scripts is, first, we want you guys to first figure out how to use the Python API that we provided for you guys for uploading and downloading the server information. And second, we want you guys to figure out what are the constraints for this whole IoT system works. What I mean by the constraints is that so in which condition or in which status of the other clients, and in what time the other clients is at that your current client should run. So these two conditions are very, very important: the status of the other clients and the time when the other clients are at. So these two conditions will be enough for you guys to infer whether the client that you are working on should run or not. And by correctly figuring out these conditions, your IoT system should function properly. However, if you guys cannot figure it out and maybe you guys choose some wrong conditions, then you will see on your RVs or on the when you guys run the whole system, you guys will see some weird things happens. Maybe like when your camera is uploading the pictures and the robot arm starts to move, something like that, or even when the robot arm is working, you can still turn the table. Those are not desired situations. So you guys need to figure out how to make the whole IoT system functions properly and in a reasonable fashion. Okay, so let's go through this scripts really quick. First, I need to look at this main function. We provide you the sample code. This is the code. This IoT.check table status. Basically, it gives you all the information that you can read from one client. So this IoT.check table status, just what it means here. Just check table status, like table information from our server. And then I'm just giving you one sample code, and there are other two clients you guys need to write about. And then this time, so basically it checks what time this table client was at last time was at when last time it runs, and this is the syntax here. We also gave you an example. You guys need to finish all these scripts. And then here, this is the most important thing I need you guys to write. So basically, you guys need to figure out what conditions you guys should let your camera client to run. This process camera basically runs the camera client. So you guys need to know when, like in which conditions that your camera client should run. And also, by the way, so for the homework here, you guys can see this student work. Please finish the server design here, and here this student work done, service design done. So basically, we get ready of some necessary code from our solutions, and we want you guys to fill in some code in this in between the student work and the student work done. One way for doing this is because we want to facilitate you guys' work, and also, yeah, basically that's the main reason. We want to help you guys finish this assignment probably more easily. And so make sure when you guys see the student work and the student work done, you know you guys need to work something. You guys need to work on something in between these two columns. Okay. Okay, let's begin. Let's continue. So basically, this condition is very important. After you guys figure out these conditions here, go to the process camera. So process camera here, and then you guys read the camera condition, read the camera informations, and then figure out how to download the informations, and then you guys can see the student work here and student work down here. Basically, you guys figure out how to download the image here by using this Iort Python API for the PHP server. So this Iort PHP server, if you guys really want to check it, so like what I said, like I mentioned above, you guys can, like I mentioned before, you guys can check it under this PS3 source folder. There's Iort arm.py. So all the codes are written in this Python functions. If you guys want to check how to use them, you guys can open it up and look at it. It shouldn't be hard for you guys to understand how to use this API. Then go back. So basically, after you guys finish the downloading thing, oh, and also I have all these requirements. So basically, under each student work and student work done, in between them, I have some instructions for you guys to finish this working block here. So almost in the almost below every student work title here, you will see some instructions and hints, and please follow all those instructions and hints to finish the work in between these two columns. So here, you guys need to figure out how to get image from server, and then in this block, you guys need to process the image. So this is what you guys have done in your PS3 too. So basically, you guys need to change. However, you guys need to change the input of the function and also maybe the output function, so that you guys match the functions match the input of this process image function and also the output of this process image functions. So basically, that's something very trivial. You just need to change input and output to finish this function here. And then you will get the image information. Basically, that's the parts information, position, orientations on the turntable. And then in this working block here, you guys need to determine the special conditions. So like I just showed you guys, what if camera detects nothing? Then you guys need to deal with that special conditions, and also and also upload something, so that the robot arm, so that the other client knows that the camera detects nothing. So you guys need to work on that in this block. And then for the so you guys don't need to take care of this upload image things here. It's just a transformation, so of the transformation of the data format, so that the image information data format matches whatever we want to upload. So the image information format matches the format for the uploading. And then here you guys need to figure out how to actually upload whatever we transform here. So basically the image information transform here to the server, and you guys need to figure out these functions here basically, and also this thing here, this sentence here, because after you guys upload the information, you guys need to let the other clients know that the camera client has already uploaded the information, so other clients should work accordingly after that. So we want you guys to think about what kind of status you guys need to set here. Okay, that's pretty much about the PS3-3 camera client. Okay, let's now go through this PS3-3 ARM client. So this client is used for motion planning. Okay, and basically after the camera client uploads the PC informations, the position and orientations of the pieces on the table, this client downloads those informations and then starts to do the motion planning jobs. So same structure here under this working block here. You guys need to figure out same thing. Basically, under which conditions this motion planner client should work. So this upload path basically runs the motion planner, and we'll go through these functions. So here in this upload path function, so first thing is that you guys need to figure out the robot arm status. So like I was saying here, you need to set the proper robot arm status to let the other client know what the robot arm is doing. So basically when the motion planning is running, so other clients need to know the status of this motion planner. So that the other clients will function accordingly. So you guys need to think about this. What kind of status that you guys need to set for the robot arm, so that when the motion planner is doing something, the robot arm does not move, and maybe the turntable will also work accordingly, according to whether work or not accordingly, and also camera will whether work or not accordingly. So under this block here, so basically same thing, you need to read the positions of the parts from the server. Basically the camera has already uploaded the PC informations, and you guys need to download all the informations, and that's it. You guys need to figure out how to download the informations. And then here it comes to the functions you guys have been written in your PS3-1, the motion planner. So this optimal path functions basically is the PS3-1 functions you guys have been written. Same thing as image processing. You guys need to change the input and output of the functions that you guys have been written, so that the input and output matches this optimal path functions. So here I have the instructions here about what kind of inputs it should be and what kind of outputs these functions these functions expects. It should be a very trivial work for you guys. again. And also same structure here. Upload the optimum path. So basically, after you guys finish the motion planner, you guys need to upload these informations to the robot arms client, and so that robot arm knows what kind of path it should follow. So figure out how to upload the path here, and then after you guys finish uploading, the tricky part comes here. After you guys upload the motion path, you guys need to set the robot arm to running, right? So after you guys upload it, then you guys the motion planner should tell the robot arm to run. However, like I just showed you guys, so this motion planner happens. This motion planner runs after the camera captures the image and also done the image processing. But when the first time that the motion planner process all this capture image, the robot arm, so the table in the area, the area of the table that is close to robot arm has nothing on it, so the robot arm cannot move. So basically, you guys need to turn the table again so that the robot arm can begin to work. Which means, after you guys done this motion planner, you guys cannot set the robot arm to run immediately because you guys have not turned, because the worker has not turned the table. So here, basically, like I said here, you guys need to think about it, like what kind of situation you need so that the robot arm runs only when the piece that just has been planned are sent to the face of the robot arm, sent to the areas that close to the robot arm. So here I give you guys some hints. Please turn the table again. So basically, I want you guys to consider. I want you guys to notice that there's an extra step here. So the worker needs to turn the table, and then the motion planner send the status, the robot arm status to run, so that robot arm run. So obviously, there's another constraint here that that you guys need to consider about when to send the robot arm to run. When to set the robot arm status to run. Okay, think about this one. This one is very tricky. So basically, that's it. That's about this assignment. So after you guys figure out how to use the server, and also after you guys put your guys' own functions in the two scripts, and then you guys should successfully run the whole sessions. And when you guys run the sessions, just follow the steps I showed at the very beginning of the video, and basically you guys will find the system, how the whole system works, just like what I have just showed. Sorry. So basically that's it. Hope you guys have fun with this homework. Bye.